Lasers. Just destroyed my camera. Lasers. How do lasers work? Now, lasers is an acronym. Light, L-A-S-E-R. Light amplification by stimulated emission of radiation. So lasers are not some sort of special carve out on the light spectrum. It's just that color of light. If you think about the colors of laser, well, we'll get to that in a second. But the three main lasers that you can buy are what three colors? That's what you should be thinking about. The three colors of lasers that you buy. All right. So what is laser light, though? We're taking and we're organizing light. And when we organize it, we can keep it from diffracting out, spreading out. So when light is normally produced, it comes out in all varieties of frequencies, reds and blues and greens, the different levels of frequencies, high, medium, low frequencies, ups and downs as it flies through the air. And also, not only that, but the light is, it's not only going up, and some is going like this, and some is going like this on its side. Some is going diagonal. So you have all different frequencies, all in different angles, and all at different points. Even if you have all blue light, it might be, this one might be going up while this one's going down. And they might be opposite each other. What we want to do is we want to organize that. Because when you have a light, the light spreads out, right? The light spreads out. It spreads out of the projector. It spreads out. The closer I bring this light box, the smaller it gets, because light spreads out. Even if I focused it with the lens back to a point, it would spread out again. Light just has this desire to spread out. So what we want to do is we want to hold it together as long as well as possible. So what we do is we want to make it not be incoherent. Incoherent is disorganized gibberish. We want it to be coherent. Like when somebody has a coherent argument, everything lines up perfectly. So we want the light to move up together and down together, to crest and trough together as it flies forward. So let's use this for an example. See, here are three colors of light, of lasers: red, blue, and green. The hardest one to make is blue. That's the hardest one to find online. That's the hardest one to make. We're going to see why in a bit. You'll never have a white laser. It's not possible. You could shine all these lasers on the one point and it will make white. If I bought all three lasers, I could shine them onto one point, but you can't have a single dot be white out of one machine here. All right. So let's take a look using, I'll click this all up so you can be reading it, but this would be like, now light's not individually colored, but they're coloring it in for us. The highest frequency blue, the lowest frequency red. We want all just one color. We don't want the light stepping on each other's feet, giving each other flat tires. So we want, this is laser light down here. It moves together. So how do we get this to look like this? We need to, first of all, just make it all just one color. If we put a blue in there, just to, be inclusive here, the blue would be bouncing all over it. We can't make it match this march as up, down, crest, trough. So we need to have it just be red. So I could put a red piece of plastic over a flashlight. It'll all be red. But it won't be this. It'll be this. Some light going up, down, some going down, others up, some left and right, diagonal. So what we have to do is not just make it all red, but we have to make it march together. When we get to march together, now it's not stepping on each other's toes, pushing each other out. It can fly along like a school of fish, not bumping into anybody, and it can go whichever direction it can go straight, because it's not bumping into anybody. The moment it bumps into somebody, it gets pushed off just a smidge, and it flies off in that direction all on its own. If I had you all outside, in a group, no social distancing, I had you all together, shoulder to shoulder, and I said, all right, everyone walk to the greenhouse, you would all spread out. That's what you do. If I said, oh, no, don't spread out, I want you to stay together, you'd have to work. Light doesn't work to stay together, it doesn't think like we do. What if I blindfolded you and said, okay, and walk to the greenhouse? You'd all end up crashing into buildings and stuff. So what I'd have to do is I'd say, we're going to walk to the greenhouse, we're going to walk in a straight line, and I'm going to help you. All right, you're going to walk, I'm going to point you, first of all, point you all the correct direction. And I have to get a couple things for you. I have to say, all right, I don't want you stepping on each other's feet. So what we're going to do is everybody's going to start when I say start. But which foot? I'm going to have to organize that too. You're all going to start with your right foot. All right, so wait till he says start. When he says start, I start with my right foot. But what if one of you takes little tiny steps and the other one takes big honking steps? So what I have to do is say, okay, I have to get a little bit more organized. You're all going to start at the same time with the right foot. You're going to take 1 meter steps. And your steps have to also be at the same pace. So I'm going to go right, left, right, left, right, left. 1 meter, 1 meter, 1 meter, 1 meter, 1 meter. If you all are doing it perfectly, you will never step on anybody's foot. Your shoulders will sway as you are supposed to sway when you walk, and you'll be swaying together too. If everybody listens carefully, and I do a good job, we will all get there in a straight line, and we'll say, stop! Take off your blindfold, and you'll all still be together. Because that's what a laser does, right? The light stays together. It doesn't spread out. It left together, march, 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 up and down together. Now, how is a laser, this is why you have to have red lasers, green lasers, or blue lasers, but you can't mix them together. Because the moment I start mixing them together, it becomes this. Even if I get the greens to work together and the reds to work together, the greens and the reds can't work together, so I can't have a yellow laser. Unless I can make a yellow wavelength itself. I can't use a combination of red and green. I'd have to have a yellow wavelength specifically. And I think that can be done, but it can't be used using the primary colors. In a light show, they would just shine the two colors together from two different lasers, and it would match. I was going to say, all right. Well, I think that's probably good enough there. I don't need to overkill lasers, but this is coherent light, this is incoherent, and this is also incoherent. All right, we need it to be together. We're doing quizzes instead of tests these days. Oh, I want to mention how a CD player works. I knew I was going to say. I was going to first say how this produces laser light. For the light to get out of here, it produces all red light, but for the light to get out, it's all jumbled in there. It has to navigate an obstacle course of gases. And if it can navigate the obstacle course, it will leave at the same up-down, the same coherentness in phase with the other red lights. Any light that's out of phase hits the gas, fails the obstacle course, gets reflected back, and has to try it again. All the light that navigates the obstacle course of gases in here makes it out coherently. Any that fail that get reflected back by the things they hit and start over. It's happening at the speed of light, so light is always going to be exiting. How a DVD player works, or a CD player, is this is ones and zeros. This is little specks on the bottom of a CD or a DVD. The light shines out, lands on the specks, and then since if it reflects back, it flashes back to the sensor. If it hits a dark spot, these pits on the CD, that's where it goes dark as it flashes back. And then you get these flash, 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 and that's computer code. If we had time, I'd go into how computer code works with ones and zeros, but we can skip that. It won't be on the test. But it goes flash, 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 flash. It's base 2 binary. Each of those flashes would be like a 1, and then the non-flash is a 0. That's the quick version of it for those who are genuinely interested. And that's how a DVD player works, CD player. Lasers are used for all sorts of things: surgery, in construction. You can buy them for your house. You can use them for targeting. With a rifle. You can in medicine, pointing things, messing with kitty cats. Okay, yeah, this stuff is kind of just for fun. This says what? Paris. It says in the spring. Look at this thing's kind of fun. Could you make this? Wait, is this the top or the edge? Okay, and then the same thing is that. Look at that. Could that fit in there? Is this the front or is this the bottom or is that the inside? Okay, just stare at it a while. This is the same as that. You can measure it on your screen if you want. These are parallel. All right. And we won't watch the Bill Nye. And as you study, just remember it's really cool stuff that's happening. And even though you're away doing your distance learning, it's important that we're learning things. And so that's why Albert Einstein says, don't look at study as a chore, look at it as a gift. A gift not only to yourself, but a gift to everybody else that is going to benefit from you one day. That you're going to help your kids. You're going to help people in your business that you work for or maybe run. And so what you know becomes a gift. A gift to the people you're working with, a gift to the people you're serving with that gift, you're selling things to, or whatever it is you're doing. and it also just gives us enlightenment and enjoyment. So hopefully you can take those words to heart and not look at studying as like oh, gross. All right, have a great day, everybody. Bye-bye.